right, we are back at AP Review. This is 2011 AB Free Response 6. Let f be the function defined by f of x is the piecewise function of -1 minus 2 sine x for x values less than or equal to 0, and e to the -4x for x values greater than 0. Part A, show that f is continuous at x equals 0. So this involves using the definition of continuity, right? So the definition of continuity is that the left-sided limit at whatever point they are asking about, here 0, is equal to the right-sided limit, is equal to the actual value of the function, right? But here, the left-sided limit and the actual value of the function are the same because of the equal to. So the limit as x approaches 0 from the left of f of x is going to use this function, which has the x values that are left of 0, including 0, right? So that's going to be a 1 minus 2 sine of 0, which is going to be a 1 minus 0 or a 1. The limit as x approaches 0 from the right, is going to use this function because these are the values that are to the right of 0. So that's going to be e to the -4 times 0, which is e to the 0, which is 1. So since they're the same number, right? So since, and for the record, f of 0 is also 1 because that would just mean use the function that's equal to, so that would be 1 minus 2 sine of 0, right, which is also 1. So since the left-sided limit equals the right-sided limit equals the actual function, that's by definition, right? So that's by definition, this is continuous. So really, they just wanted you to sort of invoke the definition of continuity. Cool. So, part B. For x not equal to 0, express f prime as a piecewise defined function. Find the value of x for which f prime of x equals -3. Okay, so the reason they specifically said not at 0, right, is that we're not going to put this equal to when we derive this, but when you derive a piecewise function, you just derive the pieces, and you keep the same boundaries with the exception of the actual breakpoint, which in this case is 0. So when I derive 1 minus 2 sine x, I'm going to get a -2 cosine of x for x values that are less than 0. And when I derive e to the -4x, I'm going to get the derivative of e to the stuff, which is e to the stuff, times the derivative of the stuff, which would be a -4. So -4 e to the -4x for x values greater than 0, right? Now they then ask me to find the values for which f prime equals -3. So we're going to see when f prime equals -3. Well, the first thing we do is check on this side. Can -2 cosine of x equal a -3? And the answer is no, because if you divide by -2, you'd get that cosine is 3/2 or 1.5, but if you recall what a cosine graph looks like, cosine values fall between 1 and -1 inclusively, right? They're never as high as 1.5. That a cosine of x maxes out at 1, so this is never going to happen. Never, okay? But we could also check when the other function, -4 e to the -4x equals a -3. Well, that would be when e to the -4x is a 3/4. We'd take the natural log to solve, so we'd get the natural log of e to the -4x equals the natural log of 3/4. These guys cancel, so we divide by -4, and I'd get that x is a -1/4, the natural log of 3/4, right? And that's my answer. And there's different ways that you could write that, but that's what we want. So I get -1/4, the natural log of 3/4. Cool. Part C. Find the average value of f on the interval from -1 to 1. So this involves, so that's my part C, involves me knowing the formula for the average value of a function, and then recognizing that this function behaves slightly differently than a typical function because it's two different pieces. So the average value of f on the interval from -1 to 1, -1 to 1, right, average value of f, should be 1 over 1 minus a -1 times the integral from -1 to 1 of f of x dx. Like, that's the formula I want, right? So that's a 1/2 the integral from -1 to 1 f of x dx. But here's the problem. This has to be split into two pieces. I need to integrate from -1 to 0 using this guy, and from 0 to 1 using this guy, because the two pieces of the function behave differently. If you were trying to picture what this looks like, these are totally fake graphs, so just ignore the fact that they're fake. But one of them looks like this, and one of them looks like this. So I'm going to find the -1 to 0, right? And again, these are totally fake graphs. But this area, I'm going to find integrating one particular curve. And then from 0 to 1, I'm going to find integrating the other curve. Again, totally fake graphs, not what they actually look like. Cool. So I'm going to have to take this formula now and say this is a 1/2 times. I'm going to integrate from -1 to 0 of f of x, which is this thing, plus the integral from 0 to 1 of this thing, right? Now the AP is going to assume you know how to integrate both of these and not give you a ton of credit for doing it, right? But remember that 1/2 sits out in front. So when I integrate this guy, this is going to become an x, right? And when I integrate sine, I get, so if you think about where sine lives, right? So I always tell my kids to do this if they have trouble with it. Let me find a spot where there's some room. Derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of sine is negative cosine. So if you're integrating sine, you're looping back to a negative cosine. So this is going to be a -2 times a negative cosine, which will be plus 2 cosine of x. And I'm evaluating that from -1 to 0. Plus, when I integrate e to the 4x, it is technically u substitution with my u being a -4x. However, you can also logic through it. If you were deriving e to the -4x, every time you derive, you'd times by -4. So if you're integrating e to the -4x, every time you integrate, you'd have to divide by a -4. So I'm going to get -1/4 e to the -4x from 0 to 1. That's what I need to plug in, and there's a 1/2 sitting out in front of all of that. So I'm going to get a 1/2 in front of. When I plug in 0, be careful, because sometimes when we plug in 0, we think, oh, things just go away, but not when there are cosines and e's. So I get 0 plus a 2 times 1, because that's what cosine of 0 is, right? Minus a -1 plus 2 cosine of -1, which, by the way, you're leaving as a cosine of -1, because that's not a number that you're able to find. Plus, over here, when I plug in 1, I'm going to get -1/4 e to the -4th. Minus, when I plug in 0, I'm going to get a -1/4 times a 1, because that's what e to the 0 is. So I have this entire ridiculous, ugly monstrosity. So let's clean this stuff up. So I'm going to buy myself some room. And I'm going to get that this is a 1/2, sorry, didn't give me enough space there, that this is a 1/2 in front of, so let's clean some stuff up. This ends up being a 2 plus a 1 minus a 2 cosine of -1. So this ends up being a 2 plus a 1 minus a 2 cosine of -1. And then over here, I have minus a 1/4 e to the -4th plus a 4th. So I'm going to combine the three things that are regular old numbers because they can be combined. I'm going to get 3 plus a 4th, right? So that's 12/4 plus 1/4, so I get 13/4. So I'm going to have this 1/2 in front of a 13/4, a -2 cosine of -1, and a -1/4 e to the -4th. When I distribute the 1/2, I get 13/8 minus a single cosine of -1 minus 1/8 e to the -4th. And that crazy, ridiculous monstrosity is my answer. Good times.